Hi everyone. So today we'll try to understand what is auto regression distributed lag, that is ARDL method for time series forecasting with an example. So the name appears to be a bit tough. It's appear to be a jargon, but the methodology that is followed is quite easy. So let's jump into it. So before we move ahead, let's understand what are endogenous variables and what are exogenous variables. So in any ecosystem, the variables that are dependent on other variables in the same ecosystem are called as endogenous variables, while as exogenous variables are the ones that are independent in nature, so they are not affected by any variable present in that ecosystem. Now, coming back to ARDL, so ARDL stands for auto regression distributed lag. So you must have get an understanding that it is more of an extension of the auto regression model. So what is an auto regression model? If I like try to summarize it up in a one liner, I'm assuming that you must be knowing about auto regression. So it's a linear equation, a linear formation where the future values of a given variable x is forecasted using its lagged version. So, for example, if you wish to forecast xt, x at timestamp t, then it is done using its past values, that is a plus beta into xt minus 1 plus gamma into xt minus 2, etc. etc. So the coefficient gets changed and we are using the past values. Now, in ARDL, apart from the AR component, that is the auto regression component, we have got three more components coming in. That is a distributed lag, seasonality, and trend. So the future forecast that we wish to make comprises of four components: self lag, plus distributed lag, plus seasonality and trend. So let's understand each of them one by one. And like finally, we will present a case for a particular forecast and see how these values takes place. So first of all, let's see the trend component. So trend is usually mathematically modeled using this equation: uh, e plus x0 plus x1 into t plus x2 into t square xk into t raised to power k. So this is an equation to represent trend mathematically. Now there would be a few questions from your side. Ki, what is this k? What is this t? So first of all, we must know that trend can be in multiple forms. It can be linear, it can be quadratic as well, or it can have a higher degree as well. In case of a linear trend, we have an equation something like this: e plus x0 plus x1 into t. In case of quadratic, we have equation like e plus x0 plus x1 into t plus x2 into t square. Uh, so similarly, the kth degree, in case of when the trend is of kth degree, the equation goes something like this: e plus x0 plus x1 into t plus x2 into t square plus xk into t raised to power k till then. So k is the degree of the trend that is persisting in the time series, while t takes a value from 1 till k, 1, 2, 3, 4, 5, 6, dot 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 till k. So in this particular equation, now we understood k, what is the value of t and what is the value of k. And depending upon the trend, that is either it's linear or quadratic, we will be placing their respective equations in the forecast in the ARDL equation. So we have now completed the first part, that is the trend part. Now moving on to the seasonality component. So seasonality component is denoted by summation of over I xi into si. So now this is something tricky that we need to understand. So what is xi and what is si? So again, like as we saw in the case of trend, the x0, x1, x2, xk were all coefficients of different terms coming in. Similarly, here xi also is coefficient of the seasonal dummy variables that we have formed. Now, what is a seasonal dummy variable? We will take a quick look into that. So if you know about one hot encoding, this is pretty similar to that. So if in a time series, uh, the seasonality, we will use an example to explain seasonal dummy variables. The seasonality is quarterly, that is the seasonality pattern is present after every 3 months. So eventually what we would be doing is that we will be dividing the entire data set that we have got. Assume that we have data for 5 years and that seasonality present is quarterly. So we will divide this data set into 4 quarters. We will create four new variables: quarter one, quarter two, quarter three, quarter four, and eventually, given the timestamp, only one of these variables would be one and all of them would be zero. So if the timestamp is 15th of January, This means that this date particularly falls in first quarter Q1. So Q1 in that case, Q1 would be 1 and rest of them would be 0. So the dummy variable would be 1000. Similarly, if the value is 15th of August, the value becomes 0010 because it falls in the third quarter. Similarly, if the seasonality is supposedly at 6 months, so we would be forming two dummy variables, that is first half year and second half year. So it's more like forming multiple variables depending upon the seasonality present, so that at least just one of the values would be 1 and rest of the values would be 0. Now, coming back to the seasonality component in our ARDL equation. So, the summation of xi goes something like this: x0 is 0 plus x1 s1 plus x2 s2 plus x3 s3. Now, as I told you that at any given timestamp, only one of the values out of these all dummy variables, that is represented by si, would be 1 and rest of them would be 0. So if assume that timestamp equals to 2nd of May, right? As we know that, and the seasonality present is quarterly. So we know that in quarter 2 we would be having 1 and rest of the values would be 0 because the time falls in quarter 2. So in that case, x1 s1 exists and rest of the values become 0 because s0 s2 and s3 are 0. And as s1 is also 1, so the only value remains, that is x1. So the whole summation of xi becomes x1. Similar, depending upon different time frame, only one of the terms out of these four terms would exist, and rest of the values would go to 0. This is how seasonal component is embedded in the forecast. Now, moving on to the the part that is just unheard, that is distributed lag. So, what is distributed lag? Distributed lag is just jargon. Basically, if you remember, we started off with the explanation of endogenous and exogenous variables. So, in that case, assume that we have a variable x that is endogenous in nature, that is dependent upon the exogenous variables present in the ecosystem, and y and z are the exogenous variables. So basically, distributed lags is the lags of the exogenous variables that we would be using in the equation. It's very easy to understand. Let's have an example. So if the distributed lag component has the order 2 1 2 comma 1, then eventually it means that for variables y and z, that are the exogenous variables present in the system, and assume that x is the endogenous variable present. So if the order is 2 comma 1, this means that we are taking the lag of second order for variable y and lag of first order for variable z. So for each exogenous variable, we will have a different order in distributed lag. So you can see that in this equation, order 2 comma 1, we have a1 into yt minus 1 plus a2 into yt minus 2 plus b1 into zt minus 1. So here you can see how we have incorporated second order lag for variable y and first order lag for variable z, because the order is given 2 comma 1. So whatever the number of exogenous variables you will have that number of orders. So if you have four variables, you will be having four orders: 2 1 2 1 or 2 2 2 2. Yeah, each order, each number representing the lag order for each exogenous variable. Now, the last part of the equation remains the auto regression. As I told you earlier, auto regression is similar to the auto regression that we have known. That is, it depends upon variable x forecast is done using its own past value. So, an AR of the auto 2 means that we are considering the last two values to forecast the next value, and forms a component like this: m1 star xt minus 1 plus m2 star xt minus 2, where m1 and m2 are coefficients. Right. Now, let's have a final example. Let's combine everything. So assume that we are forecasting some variable x at timestamp t such that, given are the conditions, we have a linear trend present in variable x, seasonality is quarterly. We have two exogenous variables y and z with order 2 and 1, and auto regression lag is of the order 2. Then our equation becomes something like this: the forecast for xt, that is e plus x0 plus x1 into t, because as I told you, the trend is linear. If it would have been quadratic, we would have had one more term plus x2 into t raised to power 2 plus. Now this forms our seasonality component. You can see four terms coming in because we have formed us seasonality is quarterly. That is why we have four dummy variables now, out of which only one would be giving us some value, else everything would be zero, as we discussed earlier. As we have said, there are two exogenous variable y and z such that the order is 2 and 1. So you can see that y has an lag order of 2, while z has a lag order of 1. And finally, the auto regression model of order 2, where we will consider last two variables, where E is the error term, K0, K1, K2, A1, A2, B1, M1, M2, everything used in this equation, all are these coefficients. And T minus 1 and T minus 1, as medium really doesn't have that some kind of formatting, don't assume it to be xt minus 1. So this T minus 1 and T minus 2 represent the past values.